Differentiation. This presentation will be part 1, the introduction. In this presentation, we'll focus on the first 4 parts, which is gradient on a straight line, gradient on a curve, what is differentiation, and rules for differentiation. Differentiation means gradient. So we use differentiation in order to find the gradient of a curve at any point. Gradient means the steepness of the line. If we start with the easiest graph, which is a straight line, we want to find the gradient of the given line here. We need to know that gradient is the steepness of the line, and gradient depends on height over base. That's why we're given this formula here, y2 minus y1. y2 minus y1 is the difference in the y-axis, which means height, and x2 minus x1 is the difference in the x-axis, which is the base. So if we want to find the gradient of this line, we need to take 2 exact points. Actually, you can take any 2 points, but we prefer to take 2 exact points. So this is one exact point, and this is another exact point. Exact point means with exact coordinates. And we need to find now height over base. So the difference in the y values is from 3 to 1. So 3 minus 1, the height is 2. The base is from 1 to 0. So 1 minus 0 is 1. Height over base, which means 2 over 1. Therefore, the gradient of this line is 2. But what about the gradient of a curve? We see that the gradient of a curve is constantly changing. It varies from a point to point. For example, if you're at this point here and you want to go climb above this line, you see that as you move along this line, the gradient decreases because it gets less and less and less steep until it comes to this point, which will be actually equal to 0. And then the gradient starts decreasing. So you see that it changes from point to point. Therefore, we can only find the gradient of a curve at a single point at a time. To find the gradient of the curve at a given point, we need to draw the tangent at that point, and hence to find the gradient of the tangent. For example, to find the gradient of the curve at x is equal to 2, so at this point here, we need to draw a tangent and then find the gradient of the tangent, which is height over base as we saw before. The height is 4, the base is 2, so height over base is equal to 2. So here to illustrate how the gradient changes as we move along the curve, the gradient here is minus 6. As we move downwards, the gradient decreases because it gets less and less steep. It comes to minus 2. Then here it's 0 because the horizontal line has no steepness. And now the gradient starts getting positive because the line is uphill. Differentiation is another method to find the gradient of a curve at any point instead of using the gradient at a single point, the tangent. So differentiation is given by this dy and dx. The notation comes from the idea of the gradient of a curve, which is y2 minus y1, x2 minus x1, which is the difference in the y values and the difference in the x values. So you see here dy and dx. Differentiation is also known as the rate of change of y with respect to x. This is more usually used in physics. The rules of differentiation. The first one, y is equal to a, where a is any number. So here this is just a horizontal line. So the gradient of a horizontal line is equal to 0. We see one example. The line y is equal to 2. The line y is equal to 2 is this horizontal line, passes from the point 2 on the y-axis. And we know that the horizontal line has 0 gradient, therefore dy dx is equal to 0. The gradient of horizontal line is always 0. The equation of these lines here, y is equal to x and the line y is equal to ax, these are the equations of a straight line. We know that the equation of a straight line, which is in the form y is equal to mx plus c, the gradient is the number in front of x. So here we see that the gradient in front of the number x is 1, therefore dy dx is 1. And the gradient in front of the number x here is a, so we see dy dx is equal to a. One example, if we want to find the gradient of the line y is equal to 3x, the line y is equal to 3x is a straight line passing from the origin. We know that the gradient is the number in front of the number x, which is number 3, so dy dx is equal to 3. For the line y is equal to 5x plus 1, y is equal to mx plus c, number in front of x is 5, so we expect dy and dx to be equal to 5. Rule 3, if we are given this form, y is equal to x to any power n, then in order to differentiate this, we bring the power in the front and we multiply, so n comes in the front and becomes multiplication, and you subtract 1 from the power. For example, if we see the graph y is equal to x squared, and we want to find the gradient of this curve, as we mentioned before, the gradient of a curve varies from point to point. So dy and dx here, we bring the number 2 in the front, it becomes multiplication, and you subtract 1 from the power, so it's 2x. What this means is that the gradient of the curve 2x is the gradient of the curve at any point. So the gradient changes as we move along the curve. It depends on the value of x. Let's see some examples. If we want to find the gradient of the curve at the point x is equal to -1, before we had to use tangent to that point and find the gradient of the tangent. But now we know that the gradient of this curve, of the curve x squared, is 2x. This is the gradient of the curve at any point. So if x is equal to -1, you substitute that point to the point 2x, the line 2x, we find that dy and dx is equal to -2. So the gradient of the curve at the point -1 is -2. If we want to find the gradient of the curve at the point x is equal to 2, then we substitute in the equation dy and dx, which is 2x, 2 times 2, it's 4. So the gradient of the curve at that point will be equal to 4. Some more examples. Y is equal to x cubed. You bring the power in the front, becomes multiplication, and you subtract 1 from the power. Therefore, you get 3x squared. X to the power of 5, you bring the number 5 in front, and you subtract 1 from the power, becomes 5x to the power of 4. And with a negative power, be careful, it's -6, but when you subtract 1 from the power, it becomes -7. And this is a general rule. Again, as before, a is a constant. You bring the power of n in the front and you multiply, and then you subtract 1 from the power. Some examples. Y is equal to 3x squared. You bring the power of 2 in the front and you multiply, so 3 times 2 becomes 6. You subtract 1 from the power, is 6x to the power of 1. 5x cubed, you bring 1 in the front, 5 times 3, 15. You subtract 1 from the power, is 15x squared. And with -5 will become -20x to the power of -6. So these are all the 4 rules we did up to now. And let's see one mixed exercise. For example, you are given this equation. Now we take each component separately and we differentiate as before. So dy and dx will be 2 times 5 is 10, so 10x to the power of 4. For this one, it's -2 times 3 is -6x to the power of -3. Remember, you subtract 1 from this one. For -4x, the gradient of this one is -4. Want to see why this is also true, as we mentioned before, but -4x, you can write this as -4x to the power of 1. So if you're going to differentiate this, you bring 1 in the front, it becomes -4 times 1. You subtract 1 from the power, it becomes 0, and we know that x to the power of 0 is just 1, therefore the answer is -4. And for the number -3 is a constant number, therefore it has 0 gradient, but let's explain this with the rules. This can also be written as -3x to the power of 0, and when we differentiate this, we bring 0 in the front, becomes multiplication, -3 times 0, and -3 times 0 is just 0.